Hello learners, welcome again to our session today. It is the second class of the concept that we introduced in our previous session. This is all about simulation analysis. Remember, this is a concept that we introduced. I gave you detailed introduction and of course detailed concept on what you need to understand when it comes to simulation analysis. So in our class today, I'll want us to handle a question, specifically a concept where I'm having simulation, we're having the net present value. How will we go about such a question? I'm going to share the question on our screen. At the same time, you can literally find this question just below the video. I've attached basically a link, and in that case, you can literally copy the link to the new tab and you can download this question. So this is our question, my good students. Let me share it here on the screen so that you all have it as you go through it. So basically this is a question that you're having. I believe that it is visible. Let us go through this question together, see what you're told and what will be required to do. We are told in this case that XYZ Limited intends to replace existing machines with a new one, which is expected to increase its profitability over the next 3 years. Good. Due to uncertainty in expected cash flows of this machine, the following estimates with associated probability has been provided. So I'm given year 1 with its cash flows and probabilities. I'm given year 2 cash flows and its probabilities. I'm given year 3 cash flows and its probabilities. The cost of capital is 12% and its initial outlay of the machine shall be 27 million. Okay. Required. We are told, using expected monetary value, calculate the expected NPV of investing in the machine. Part B, analyze the risk inherent in the situation above by simulating NPV calculation and hence calculate the resultant NPV. Good. Simulating NPV calculations and hence calculate the resultant NPV. Part C, what is the probability of the new machine generating negative results? A very good question. Then our good examiner here has given us what? Use the following random numbers. And clearly you can see random numbers I'm given into 2 digits. Because also if you can check probability, you can clearly see that our probability were also in 2 digits form. Right? So that will simplify our work. And how are we going to go about it, my good students? This is how we are going to work it out. Allow me to erase here. Allow me to erase here. Allow me to erase here so that we work out that question and we'll clearly agree with Mwalimu that this is a very simple concept that if you have it at your fingertips, things will be very, very easy. Okay? Things should be very, very easy. So allow me to basically squeeze this question. Let us squeeze it somewhere there. So the first thing that our good examiner wants us to do is to literally work out our expected, to determine expected, using expected monetary value, calculate the expected NPV of investing in the machine. Calculate basically the expected NPV of investing in the machine. So this, my good students, will be very simple. And how will we go about it? Because at this point, we all know by now that literally for us to determine our NPV, we must always talk of what? Our net present value will always be determined by taking our present value of the cash flows, right, with less our initial outlay. We all know this. We all know this. And I've always basically explained that concept in every question that has NPV. So today, let us just do it directly. So at this point, that is to say, I should be having the present values. But the good thing here with our examiner is giving us the expected. So how will we go about it? At this point, first of all, we should now incorporate, of course, our expected cash flows. So in this case, I need to have expected NPV. Therefore, I should be having expected cash flows minus our initial outlay, right? Minus our initial outlay. This is what will give us our expected net present value. So, how will you determine our expected cash flows, my good students? Determining our expected cash flows at this point, this is what we should be having. This is what we should be having. Expected cash flows. This is literally what we need to, this is what we need to determine. So, I'm going to take year one cash flows. This is year one. Our cash flows will be what? I should be having 10,000, clearly see that, times probability, which is 0.3, 0. I'm going to add 12,000 times probability, which is 0.40. We are going to add 20,000 times probability, which is 0.20. Then finally, we are going to add 25,000 times probability, which is 0.1. So this will give us expected cash flows of. So let us work it out quickly. 10,000 times 0.3. We add 12,000 times 0.4. We add 20,000 by 0.2. We add 25,000 by 0.1. So in this case, first of all, I can see that we are getting how much? 14,300. So this will be our expected cash flows. 14,300. That is year one. What about year two, my good students? The same procedure will apply year two. Can you give for Mwalimu year two kindly? Can you compute for Mwalimu? Can you work it out for Mwalimu for that year two? The same procedure will apply. Check year two. Year two, what do we have? 10,000, right? Times 0.30. We add 15,000 by 0.20. We add 6,000 by 0.20. We add 7,000 by 0.3. What should we be having there quickly? I'm going to get a figure of 10,000 by 0.3. We add 15,000 by 0.2. We add 6,000 by 0.2. We add 7,000 by 0.3. Mwalimu is getting a figure of how much? 9,300. You can confirm, guys, kindly. I'm getting 9,300. Expected cash flows. We are looking at year 3 now. Year 3, what will we be having? The same procedure will apply, which literally now you can do it very comfortably. So I'm going to do it quickly. So I'm going just to work it out quickly using my calculator at once so that we have it directly. I'm having basically into bracket 10,000 times 0.3 plus 8,000 by 0.5 plus 10,000 by 0.2. So I'm getting 9,000. So this is our cash flows for expected cash flows in year 3. I've just worked it out now directly on my calculator. So we're having 9,000. So once we have that case, my good students, what is the next step that we need to do? The next step here is for us to work out our NPV. For us to determine our NPV, expected NPV. Now, very confidently, I can say that therefore my NPV in this case will be as follows. My NPV here will be as follows. I'm going to have the cash flows. Here we can see that they are what? They are irregular cash flows. And if they are irregular cash flows, what will click at the back of our mind, my good students? The concept to do with our interest factor, which should be present value interest factor, given the rate a number of years. That is what should click at the back of our mind, because I am dealing with irregular cash flows. Do you recall that formula of present value interest factor, where we should be having this case 1 plus r raised to power negative n? I need for year 1, year 2, and year 3. What will we be having here? Whatever that I should be having here, basically, I should be talking of 1.12 raised to power negative 1, 1.12, because the discount rate you are given what? 12%, right? Negative 2, 1.12 raised to power negative 3. That is what we should be having. This is what we should be having here. So that year 1, therefore, I'm going to have 1.12 raised to power negative 1, which should give me a figure of 0.89 29 divided by 1.12 to give me 0.79 72. That is for year 2. Year 3 divided by 1.12, which will give me 0.7118. So I've literally determined our present value interest factor for the 3 years. After that, now things will be very easy. Just see how these things will be very easy. The next procedure will be what, my good students? I've already computed we've already calculated basically, of course, our expected cash flows here. So therefore, I can confidently come and determine our expected NPV. So therefore, my expected NPV will be as follows. Expected cash flow year 1 is 14,300 times present value interest factor year 1, which is 0.8929. We add expected cash flow year 2, 9,300 times the present value interest factor year 2, 0.7972. We are going to add year 3. I should be talking of 9,000 cash flows times our factor 0.7118. So this should give us how much? At this point, let me just hide this question for a while. Yeah, I should be having that. So once we have that case, what will we be having here? Confidently, we can come and say that I'm having, this is now what we are referring to as present value. You see, present value of our cash flows. Present value for cash flows. So my present value for cash flows, therefore, we should be talking of 14,300 times 0.8929. We add 9,300 by 0.7972. we are going to add, my good students, 9,000 by 0.7118. So this should give us our present value to be 26. This is our present value, 26,588.63. Less what? Initial outlay. Less initial outlay. So our initial outlay, how much did we invest, or were we intending to invest? We were intending to invest. If you can check in our question here, we were intending to invest how much? Cost of capital is 12%, and the initial outlay of the machine shall be 27 million. So our investment value, initial outlay, is 27 million. So I'm having initial outlay of 27 million. So this is to say that our NPV, will be, our expected NPV at this point, I should be talking of my answer minus 27, negative 411.37. This will be our expected NPV up to that point, my good students. Are we good up to that point? Great. I believe that we are good. Let's proceed to the next question. So literally what we've done, we've just determined what? The expected NPV, right? So proceed to the next question. What were we told? We are told to now analyze the risk inherent. I believe that now is clear. Analyze the risk inherent in the situation above by simulating NPV calculations, and hence calculate the resultant NPV. So here is now where we are going to apply the concept of simulation analysis, which again you'll find it to be very, very, very easy. Which again here you'll find it to be very, very easy. So what I want you guys to do is to mark for me what we've done. Just put it somewhere. In the event that you need to make a reference to that, of course it will be easy. So in this case, we need to prepare basically our random table. Before simulation worksheet, this is what we need to do. We need to prepare basically our random number ranges. Remember the steps that Mwalimu gave us? So allow me to erase this point. Allow me to basically erase this point here. First step is to prepare basically our random number ranges. So in this case, I need to prepare my random number ranges. Random number ranges, or range, okay? So in that case, what will you be having? Take all the data that I was given for each year, exactly what I was given there. Exactly what I was given there. I want us to take the data that you're given there, because it is the same that I want us now to use here. We start by year 1. So these are our years. Okay? These are our years. In our years, we are having the following. I'm having our cash flows here. Okay? We are having our probabilities, cumulative probabilities, and I want us to have now our basically random numbers. We are preparing our random number ranges. That is what we should be having. Okay? So let us start. Year 1, I'm having cash flows as follows: 10,000, 12,000, 20,000, and 25,000. Year 2, we are having, this is year 2. Y2, I'm having 10,000, 15,000, 6,000, and 7,000. Year 3, we are having 10,000, 8,000, and 10,000. See what we have. Okay? Jump to probabilities. 0.3, year 1, 0, 0.40, 0.20, 0.10, 0.30, 0.20, 0.20, 0.30. Okay? 0.30, 0.50, and 0.20. I don't need this question anymore. So let us basically hide the question. So in this case, our cumulative probability will be, the first one here I'm talking of 0.30, 0.70, 0.90, then I'm having 1.00. Our cumulative probability, right, for each period. Year 2, 0.30, 0.50, basically 0.3 plus 0.20, 0.5 plus 0.20 should give us 0.70, then I'm having 1.00. The other case here, I'm having 0.30, 0.80, and 1.00. Believing that you are on the same up to that point. Kindly, if you are on, we are on the same page, raise up your hand so I cannot see you, but it's okay. So, squeezing it here. This is cumulative probabilities, of course. Cumulative probability. Now, our random number ranges. So, interesting, these will be our random number ranges. Okay, I'm having the first one, that should be 00 to lower limit, which is 29, 30 to lower limit of 70, which is 69, 70 to lower limit of 90, which is 89, 90 to lower limit of 100, which is 99. Confirm that we are on the same page, kindly. The next range will be, remember that is year 1. Year 2, 00 to 29. Excuse, 29, this is 30 to 49. 50 to 69. 70 to 99. Year 3, 00 to 30. This is 29, lower limit. 30 to 79, lower limit. And 80 to 99. What you can observe here, my good student, is Mwalimu is picking our range to be 2 digits. Why are we picking our range to be 2 digits? We are picking our range to be in 2 digits simply because we can see that our probability here, we have them in 2 decimal places. And that's why Mwalimu here is taking our ranges to be in 2 digits. If we had 1 digit, as I explained earlier on, we could be having only 1 digit. Okay? So here is our random number ranges. What is the next step that we should do? The next step here is literally to prepare our, what we normally refer to as simulation worksheet. So this is how we are going to prepare our simulation worksheet. Just a moment here. This is how we are going to prepare our simulation worksheet. Our simulation worksheet. Our simulation worksheet. So, just a moment. Our simulation worksheet will be very easy. Our simulation worksheet basically will be Very, very easy here. So let us prepare our simulation worksheet. So I'm having here simulation worksheet. Our simulation worksheet. So these are our simulation worksheet will be. Remember, I'll be using what? I'll be using our ranges. I'll be using literally our ranges. I'll be using literally our ranges. So to prepare that, this is how you're supposed to work it out. That is a simulation worksheet. So I should be talking of our runs. So, and in this case, I'm going to have based on our years, right? The years that you are given year 1, year 2, and year 3. So this is what you should be having, clearly, my good students, and have it right. We are going to have, of course, our runs here. We are going to have the cash flows. We're going to have, of course, our cash flows here. We're going to have our cash flows. Because we had a discount factor, actually, let us just incorporate it at once so that it will make our work to be very, very easy. So I'm having basically our runs, okay? We're having, of course, our random number here. I'll be having our cash flows, okay? So random number, year 2, our cash flows, year 2. Random number here, we're having our cash flows here, okay? So that, of course, once we have that, literally, what we'll do next is basically to determine what? To determine or to deduct our initial outlay. What I'll be having next is literally to deduct our initial outlay. So how will we go about this? We're given our random number. Will it fit for us to have our initial outlay? We can literally have basically our initial outlay, so that we're having what? Our NPV at that point. So that we have our NPV at that point. So that we have our NPV at that point. So once we have this, let us start. Random numbers, let me write for you here random numbers, the one that we are given. Our random numbers we are given as follows, as per the question, but I don't want to display that question to save us space. I'll be having 43, 23, 66, 76 here. That is 24, 78. While doing this, your eyes need to be very, very sober. 90, 07, 45, 28, 46, 30, 19, 72, 83, 58, 49, and 02. That is what you are given as our ranges. And basically, where Mwalimu is getting the figures, this is where Mwalimu is getting the figures. You see this? We had it. The figures down there. You see the figures? That is where I'm getting the figures. That is where we are getting the figures, okay? So once we have that, let us start. Our first run, which I'm going to have it as number 1. The first random number is 43. So in this case, we are looking at it. I should be having basically like, this is year 1. I hope it will fit. This is basically year 1, okay? This is year 2. This is year 3. Initial outlay, NPV. So, having this, the first random number will be what? At this point, I know you're going to ask Mwalimu, why is your line not straight? Are you a member? Mwalimu, why are your lines not straight? Are you a member? One will ask which member of which club? I know you know. I know you know. I know you know. Member of which club? I know you know. So, this is what we should be having. The first random number, my good students, I'm having 43. So where will 43 falls? Having my 43 at this point, having my 43 at that point, our cash flows, in this case, year 1, looking at year 1, right? So just come to year 1. Where is 43 falling? 43 is falling in between 30 and 69. So therefore, my cash flow should be 20, or rather my cash flow should be 12,000, right? So I'm going to have here our 12,000. We proceed to basically, that should be year 2, assigning the second random number. So basically we are done with that. 23. Our cash flow in that case, we should be having what? Year 2. 23 is falling in between 0, 0 to 29. So our cash flow is 10,000. So I'm going to have about 10,000 at that point. What about year 3? The third random number, which is 66. So I'm having here 66. Cash flow is falling. Where is cash flow? 66, year 3. Our cash flow is falling in between 30 and 79. So therefore my cash flow here between 30 and 79. So our cash flow here is at 8,000. So basically I'm going to have here our 8,000. Believing that we are good up to that point, digest it fast. Digest it. I want you guys to digest that. We proceed to the second bit. So we are done with these random numbers. The other random number is 76. So I'm going to have run 2. 76. Where is our 76 falling in year 1? 76 is falling in between 70 and 89, which will give us what? 20,000. The next random number is 24. Where is 24 falling in year 2? 24 is falling in between 0, 0 to 10, 29. So therefore, again, this is 10,000. What about the other random number here, 78? Where is 78 falling in year 3? 78 is falling where? In between 30 and 79. So basically, it's also 8,000. So we are done with that bit. The third run. Third run, random number is 90. So I'll be having 90 here. Why is 90 falling in year 1? 90 is falling in between 90 and 99, which is 25,000. I'm having 07 here. Where is 07 falling? 07 is falling in year 2. Of course, 90, you say that in year 1, this one is falling here. Now 07 in year 2 is falling in between 00 and 29, which is again 10,000, right? The other random number is 45. Where is 45 falling in year 3? I'll come to, this is a 45. So where is 45 falling in year 3? 45 is falling in between 30 and 79. So therefore, again, I'm going to have what? 8,000. I really hope that you guys, you're getting this concept right. Should Mwalimu leave it for us to do the rest? Confirm if it's a yes or no. Should Mwalimu leave it for us to do the rest? I know one will say, Mwalimu, maliza kazi yako. Mwalimu, finish your work. Let me finish my work then. So you're done with 45. We go to the fourth run. The fourth run, basically I'm having 28. So literally I'm having here 28. So 28, basically what do we have in the first year? 28 is falling, basically 0029. So 28 is falling at 10,000. So you're done with that. I'm having 46, year 2. Where is 46 falling in year 2? 46 is falling in between 30 to, basically, of course, 49. So literally in that case, I should be having, that is 15,000, right? That is basically 15,000. So I'm done with that bit. That is 46. We go to 30. Where is 30 falling? 30 here. Where is 30 falling? My 30 is falling in year 3 in between 30 to 79 again. So basically I should be having 8,000 here. We proceed to the next run. So you're done with 30. Proceeding to the next run, which is run number 5. Run number 5, what should we be having here? Our run number 5 here, we should be talking of run number 5 here, we should be talking of, so you're done with 30, I'm having 19. So 19, year 1, where is it falling? It's falling in between 00 to 29, which is 10,000. 72, year 2. 72 is falling in between 70 to 99, which is 7,000. 83. Where is 83 falling in year 3? 83 is falling in between 80 to 99 here, right? So basically I should be having what? 10,000. Then we have the next run here, which is what? Run number 6. Run number 6, my good students, again the same procedure applies. What will we be having here? I should be talking of 58. Where is 58 falling? 58 is falling in between 30 and 69, which is literally 12,000. The next run is 49. Where is 49 falling? 49 is falling in year 2, is falling in between 30 to 49, which is 15,000. What about the last bit, 02? 02 in year 3 is falling on the first one, which is 0029. Our cash flow is 10,000. So what we've literally done, we've just prepared our simulation worksheet. But will our work end there? No, our work will not end there, because our target here is to prepare our NPVs, right? Our target here basically is to prepare our NPVs. So this will make our work even much easier. Why is Mwalimu saying that our work will be much easier? Our work will be much easier because, remember, we had already computed our discount factors, right? What was the discount factor in year 1? Kindly just go back and see what we had. In year 1, we had 1.12 raised power negative 1, which gave us 0.8929. Remember that we had already worked it out. Year 2, we had 0.7972. Year 3, we had 0.7118. I know you remember that. I know you remember that. I know you remember that. Now, the most interesting part in computing our NPV, we know our initial outlay. Is that right? We know our initial outlay. Our initial outlay, we had how much? Our initial outlay all through will be 27,000, right? 27,000, 27,000, 27,000, or will you allow mwalimu to have 27 because of our space, right? Allow mwalimu to have basically 27,000. Let's just have it as 27 so that we should not redo it again anywhere else. So just a moment here. Allow mwalimu kindly to have this. I know we are supposed to follow the standard format. If it is in thousands, we should be having thousands. But for the purpose of understanding, so that we can save space for NPV, allow me to just have here as 27. Okay, kindly. But at the back of our mind, of course, you know very well that we'll be talking of what? We'll be talking of basically, we'll be talking of thousands. So allow me just to have 27 there. But we know it is in thousands, okay? So this is what I want us to do. This is what I want us to do. And kindly at this point, concentrate with mwalimu. Put all your attention here. Put all your attention here. Put all your attention at this point. Put all your attention at this point. So that you see how this thing is simple. I need my NPV. So I should be having this case. The first one I'm having basically 12,000. Okay? I'm doing the first run. We're having 12,000 here. We multiply by our discount factor, which is 0.8929. Okay? We are going to add 10,000. We multiply by our discount factor, which is 0.7972. Okay? We add 8,000 times our discount factor, which is 0.7118. I'm just taking our cash flows times our discount factors. Okay? So what will we be having here? I'm going to have our 12,000 by 0.8929. Okay? We add our 10,000 by 0.7972. We add 8,000 by 0.7118. So that will give me basically 24,381.2. I deduct our 27,000 initial outlay, so that our NPV, my good students, my NPV, we should be having negative 2618.8. So confidently come and have here, and I want to write it with a different pen. Where is my blue pen? I want to write it basically with a different pen to insist what we are talking about here. So here, confidently, I'll come and say that my NPV is negative 2618.8. Is it home? Is the message home? That is what I want us to understand. Is the message home? I believe the message is home. We proceed with the next item here. Now, run number 2. What will we be having in run number 2? Run number 2, I'm going to have, so here we say that this one is minus 27,000, right? All of that minus 27,000, that is what I'm getting there. Come to run number 2. Run number 2, basically I should be having cash flow 20 by 0.8929. Cash flow 10,000 by 0.7972. Cash flows 8,000 by 0.7118. This should give us what? Minus 27,000. This should give us, my good students, I'm having 20,000 by 0.8929. 20,000 by 0.8929. We add, that is by 0.8929. We are going to add, of course, 10,000 by 0.7972. We add 8,000 by 0.7118 minus 27,000. My good students, I'm getting 4524.4. Kindly confirm with your figures. Kindly confirm if you're getting the same item, the same value. So you said you're using a different pen here. So I'm having 4524.4. The next run, now allow me to do it directly because this is a flow. That is a flow. So I'll be having 25,000 times 0.8929. We add 10,000 by 0.7972. We add 8,000 by 0.7118. So having that case minus 27,000, this will give us 88.9. So we are done with that, with these three runs. The fourth run, the same procedure will apply. 10,000 times 0.8929. We add 15,000 by 0.7972. We are going to add, that is of course 8,000 by 0.7118. So basically I'm having 8,000, 15,000, 10,000. Okay, minus 27,000. I'm getting negative 418. You can confirm. I'm getting negative 418.6. Kindly confirm. So that the next item here we are having 10,000 by 0.8929. We are going to add 7,000 by 0.7972. We are going to add 10,000 by 0.7118. So this should give us 21,267 minus 27,000. I'm having negative 5372.6. Lastly, we are having 12,000 by 0.8929 plus 15,000 by 0.7972 plus 10,000 by 0.7118 minus 27,000. I'm having 2790.8. So that is what you are having here as our random numbers. That is what you're having there as our random numbers as well as our NPV. Remember, we can't clear that till we determine what? The resultant NPV now. That is the summation, because that is what you are asked. So what will be our resultant NPV? Resultant NPV, that will be simple. You come and sum up all this. Plus minus 5372.6. I've started from below. Plus minus 418.6. Plus 8988.9. Plus 4524.4. Plus minus 2618.8. So this should give us resultant NPV to be 7894.1. That should be our resultant NPV. resultant NPV. Or the examiner wanted us to do what? What the examiner wanted us to determine. NPV, that is what the examiner wanted us to determine, resultant NPV. So literally, that is what you are required to do up to that point. Was there any question on that? Let me check. You do have any other question? What is the probability of the new machine generating negative results? That was part C. What is the probability of the new machine generating negative results? That is simple. That is simple. And why is Mwalimu saying it is simple? Look at where we're having negatives. How many negatives of the total? So, probability of the machine generating negative NPV, of the machine generating negative NPV will be, how many negatives do you have? 1, 2, 3. I'm having 3. Of the total expected, you had how many runs? 6. So 3 divided by 6. So the probability here should be 0.5. So there is a probability of 0.5 that this machine will generate what? Will generate a negative NPV. And this is what you are literally required to do in that question. You can see it is a wide question, but also very, very interesting, right? So to that point, guys, I want us to meet in the next session. We handled another question for simulation analysis, but we will be looking at a question from our past paper, which ideally you'll see it is exactly the same concept that is always tested. To this point, see you next when we'll be handling another question. Thank you, guys.